Okay, adding and subtracting algebraic fractions. Okay, this is actually very, very similar to how we add and subtract normal fractions. So let's have a look at it. 1/3 plus 1/4. We can't add these yet because we need the bottom to be the same size. This needs to be the same number because they're numbers. In this case, there's no common factors. So what we do is we say that that is the same as 4/12 plus 3/12. So what we've actually done there is we've times top and bottom here by 4 and top and bottom here by 3. This means that this number is still a third and this number is still a quarter, but now they have the same size in the bottom, which means we can just add them. 4 plus 3 is 7/12. Done. Right? That's how we deal with fractions normally. Okay? Now, if they have a common factor already, like this, we don't want to do 6 times 9, because if we do that, we're going to have a far more complicated answer than we need. So, if I times this top and bottom by 3, and this top and bottom by 2, the bottoms will be 18. So the left-hand side, we times by 3, so we get 3/18. The left-hand side, right-hand side even, we times by 2, so we get 2/18. They're now the same size, 3 plus 2 is 5. So we get 5/18. Okay? And that is how we've dealt with fractions in the past. So now, we're going to do that with algebra. Okay? So, our first problem, y over 5 plus y over 3. Well, all we have to do is make the bottoms the same size, and then we can add them. So we have 5s, 5ths, and thirds. We're going to make those into 15ths. So, we times the left-hand side one by 3. So we get 3y over 15. We times the right-hand side by 5. So we get 5y over 15. They're now over the same number, so we can add them. 3y plus 5y is 8y. Done. Okay, now this next one is a touch more difficult, but it's the same concept. We've got 3 over x plus 2 over 3x. Okay, we need the bottom to be the same size, so we need to turn x into 3x. How do we do that? Well, we times by 3, right? So, we times the left-hand side by 3, and we'll have 9 over 3x. Right-hand side we don't need to change, so plus 2 over 3x. So that's now 11 over 3x. Now, at this point, you might feel like, oh, this isn't this top heavy because 11 is bigger than 3. No, it's not. We've got x's in there, so we leave it like this. Okay? If that happened to me 12 over 3, we could have cancelled down a bit, but that's not top heavy because x could be a million, x could be 0.001. We don't know. Okay? Right. Next problem. 3 over p plus 1 over p squared. What do I times p by to get to p squared? Well, I times it by p. And therefore, I'm going to times the top by p. So I'm going to get 3p over p squared plus 1 over p squared. The bottoms are now the same, so we get 3p plus 1 over p squared. That's it. Okay? So conceptually, I hope you can see that these are very, very similar to what we've been dealing before when we're just doing normal fractions. I'm now going to have a go at a couple more difficult problems so you can see how this extends and where it goes to next. Okay? So, this problem is quite complicated. You might feel that you want to times this side top and bottom by x plus 2 and this side top and bottom by x squared plus 3x plus 2. It's really not nice. And actually, we don't want to do that because at GCSE levels, we just won't be dealing with x cubes. Or and on the bottom here, if we times this out, we get an x cubed. So, the first trick you need to see to deal with this, not changing the left-hand side at all yet, is that's a quadratic on the bottom on the right-hand side. And so that can be written, if we factorise it, so now we can see that they've already both got an x plus 2 on the bottom, right? They've already got a factor of that. So in order to make this side the same as that side, all I got to do is times by x plus 1. So I'll get x plus 1 over x plus 2 x plus 1 plus 1 over x plus 2 x plus 1. And that is going to equal x plus 2 over x plus 2 x plus 1. Now, at this stage, we'd often be finished, but we just need to check, is there anything, can I divide everything on the top by something and everything on the bottom? And in this case, we can. We got an x plus 2 times 1 on the top and an x plus 2 on the bottom. So we can now cancel those. So that leaves us with 1 over x plus 1. So this quite complicated problem has come out quite nicely, and the tricks that you need to see there, well, this quadratic can be made up of two different factors. Then you check and you find, as expected, this is one of those factors, so we don't need to times it by the whole of that, we only need to times it by x plus 1, top and bottom. They now have the same bottoms, so we can just add them together, and then and then you just need to check that the top here is x plus 2 if it cancels with anything on the bottom, which in this case it does. Okay, so that's that complicated one done. The next one over here, all we need to know is, what do I need the bottoms to be? So they're the same. Well, this is an x times a z, this is an x times a y, so they've both got an x in them. If I timesed this by y and I timesed this by z, then they would have the same bottom. So let's do that. Times in the left hand side by y, I get p y squared over xyz. I'm taking away 5 times the right hand side by z, mz over xyz. Now this question actually has a minus sign in it, but as you'll see in the next step, we're not really going to be dealing with that minus sign in this level, because we get p y squared minus mz all over xyz. Now that's as far as we can actually get the answer to go. Okay, so we're not really dealing with this minus. You just got to remember that the minus sign here means that it works just like like adding, except that we would take it away at the end. And this we can't simplify. So although it doesn't look nice, that's how you leave your answer. Moving on to the last part now, I just want to talk about how we actually will deal with taking away. Well, what we'll do, let's look at this problem here. Right, this looks kind of similar to what we did before, so let's see if we can factorize it. We have 1 over x plus 3 minus 1 over, factorizing that quadratic, we get x plus 3, x plus 2. Oh, fantastic. So they've both got an x plus 3 in them. So this one, I'm going to times top and bottom by x plus 2. So I'll have x plus 2 over x plus 3, x plus 2, minus 1 over x plus 3, x plus 2. Okay, they're now both together, so I can just bring them to one line. X plus 2 minus 1 over x plus 3, x plus 2. 2 minus 1 is 1, so we get x plus 1 over x plus 3, x plus 2. And now we check, does this cancel? Well, no, because we'd need one of these terms to be x plus 1. It's not, so that is our answer. Okay, so you see it was exactly the same as adding, except that we just had to take these numbers away rather than adding them up. Last problem. We've got an x on the left hand side and a p on the bottom, and we've got an x squared and a y. So we're going to need an extra x here to get to be x squared, and we're going to need a y here, so we're going to times this lot by xy. So we're going to get xyu over x squared yp minus, on the right hand side we need a p on the bottom, so we're going to get 3cp over x squared yp. They now have the same bottom, xyh minus 3cp all over x squared yp. Okay, and that will be done. Now I realise this doesn't look nice, however it's very useful for us to be able to do this when we get on to the next stage of things, which is solving. And that is us.